Hello, I'm Seema and welcome to part 4 of the videos titled Electronic Configuration of Elements. We have now done the electronic configurations up to nickel. Nickel was atomic number 28, and now we come to the next configuration, which is copper. Just like chromium, copper also is an element which shows abnormal configuration. And as I told you, let me discuss the 3 points again. Why half-filled and completely filled shells or subshells are more stable. The first reason is that the electrons, they repel each other, they try to occupy the orbitals singly first, and therefore the half-filled orbitals are more stable. That is singly occupied. The first 5 electrons would go to the 5 orbitals, degenerate orbitals of the d subshell. Then the next reason is that these are half-filled when the orbitals are completely half-filled or they are completely filled. At that time, the configuration is more symmetrical, or the structure of an atom is more symmetrical, and nature always supports symmetry. If you notice, your own you would always like things which are more symmetrical. It's nature. It's not just human nature. That's how the universe is made. Symmetry is appreciated, it is desired, it is desirable. So the half-filled orbitals or completely filled orbitals are more symmetrical, and that's why they are more stable. And the third reason is the exchange energy, that when they are half-filled or completely filled, the number of exchanges that are possible, the possibilities of exchanges increases. And as the possibility of exchanges increases, the exchange energy increases. And this exchange energy is the energy which is released when exchanges take place. And therefore, they lead to the stability of the atom. And hence, such configurations are supported. One such example again is copper. Copper has atomic number 29, and let us talk of nickel again. Nickel was argon configuration, and then the argon, that is 18 electrons, 19, 20 went to 4s, and then the 3d started filling up. 5, 6, 7 and 8. 8th electron came to 3d and paired the third 3d orbital. Now copper, if you only followed the first 3 rules, you would expect its configuration to be argon, 3d, 9 and 4s2. But again, 3d, 9 and 4s2, instead of that, 3d9, 1 electron of course comes here, but to make this completely filled, the 4s electron, one of the 4s electrons now jumps from here and comes up to 3d. Although the energy of 4s is lower and 3d is higher, yet 1 electron jumps from the 4s to 3d in order to make it completely filled, and which leads to further stability. And 4s is only one orbital, therefore the energy difference between the completely filled and half filled, it would still be somewhat stable because it is now half filled. But the stability that it renders to the 3d orbitals by making 5 orbitals, making them completely filled, making them more stable, increasing the exchange energy, making it more symmetrical, leads to a greater stability. Therefore, the configuration of copper now would be 3d and 4s. 3d would be 10 and 4s would be 1. So this is again an abnormal configuration, and in textbooks you usually find it with an asterisk, the configuration of copper. Then comes the 30th element, zinc. As expected, zinc now is the 30th electron. 4s already has its electron now, and this electron should go into the 3d orbital. So this would have configuration of argon, 3d, 10, 4s, 2. If I expand the argon now, or let me just give you the complete configuration of zinc, it would be 1s2, 2s2. Now we are taking 20 electrons. These are 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18, 18 plus 10, 18 plus 10, 28, 28 plus 2, 30. So we have all 30 electrons. So how will we write down the detailed configuration? It would be 1s2, 2s2, 2p6, 3s2, 3p6, 3d10 and 4s2. Although we write it this way, the actual filling up is 4s fills up before 3d. That we see from this table. So this was electronic configuration and how we do it, how we follow the rules, and we just learn this, memorize this one table which you really don't have to memorize. It's simple. 1s, the first shell has only one orbital, one subshell, that is 1s. Second has 2, 2s, 2p. Third has 3, 3s, 3p, 3d. 4s has 4, 4s, 4p, 4d, 4f. 5 has 5 but we write only 4. 6 has 6 but we write only 3. And 7 has 2. Make diagonal lines and you are good to go. So electronic configuration is easy to write once you understand these basic rules. And once you start understanding this and you start solving it on your own, believe me, it's thrilling. It's fun to do it. I hope you enjoy your electronic configurations now. Not only now while you're practicing it, even more during the exams. All the best for them. Keep watching my videos, like them if they help you, and subscribe to my channel. Please recommend it to your friends and keep returning for more videos in chemistry. Bye-bye.